Hi friends, we are going to study about introduction of laser. In this video, the following will be discussed. What is laser? What are the properties of laser? What are the principles behind of that laser? How laser is produced? What is laser? The acronym for laser is light amplification by stimulated emission of radiation. So, the first letters from that each word will coin laser. Now, let us see the properties of laser. We can say that major characteristics of laser. These properties are entirely different from ordinary light sources. They are highly monochromatic, that is one specific color it has. Highly coherent, all the emitted photons are in same phase. Highly directional, we can send this beam to the moon. Since it is very directional, it is high intense. So, these are the very important characteristics of laser. The packet of or bundle of light, it behaves as a particle. Photon can be represented as shown in the figure. A single photon has an energy which is given by E is equal to h nu, where nu is the frequency, h is Planck's constant. Frequency is nothing but c by lambda, that is velocity of light divided by wavelength of the light. This animation will give the clear ideas about Bohr's atom model. First point, that all the electrons are revolved around the nucleus in definite orbit. The second point is, when an external energy is given to an electron in the lower orbit, which has lower energy, it transits to higher orbit, which is higher energy. So, according to this diagram, E1 has lower energy, E3 is higher energy. So, external energy is given to an electron in the lower orbit, it transits to higher orbit. Next point is, when an electron jumps from higher energy to lower energy, it generates photon. That energy of that photon E is equal to E3 minus E2, that is the difference between the energies of the orbits E3 and E2. For our convenience, instead of represent the circular orbits, we consider a straight line as energy level. Lower orbit has lower energy, which is called as ground state, and higher orbit has higher energy, called as excited state. So, according to the figure, E1 is the ground state, which has lower energy, E4 is the excited state, which has higher energy. Einstein's principle is very important phenomenon of the introduction of laser. Consider an atom has two energy levels, namely E1 and E2. E1 is ground state, which has lower energy, E2 is excited state, that is higher energy. If energy is given to this atom, it undergoes three processes, namely absorption, spontaneous emission and stimulated emission. Let us see what is absorption. Absorption is the process in which the electron in the E1 absorbs the external energy and transit to E2. Here E1 is the ground state, E2 is excited state. That process is called absorption. After reaching excited state, the electron should return back to the ground state since it is unstable state. So, there are two ways to return back. The first one is spontaneous emission, the second one is stimulated emission. Now, let us see what is spontaneous emission. Spontaneous emission is the process in which the electron returns to the ground state from excited state without triggering. Here also radiation is generated, but it is in non-radiative transition. Next, the third one is stimulated emission. The last process is stimulated emission, in which the electron returns to the ground state from excited state with triggering. This is the key factor of laser. The incident photon and the emitted photon are in same phase. So, according to Bohr, when an electron jumps from excited to ground state, it emits photon. These two photons are having same phase. This is very important phenomenon in laser. This is a very important technical term in laser action. In general, more number of electrons present in the ground state compared to the excited state. Here, N1 represents the number of electrons in the E1, N2 is number of electrons in the E2. So, in normal population, N1 is greater than N2. Next, the population inversion. By giving some external energy to the electrons in the ground state and transited to excited state, for continuous supply of energy, the number of electrons in the ground state transited to excited state. Now, N2 is greater than N1. At this moment, a small amount of energy is enough to stimulate the electrons to the excited state, easily move back to ground state, and hence it produces the radiation. So, population inversion is very important. In order to achieve the population inversion, we have to use pumping method. So, pumping method is nothing but is the process of producing population inversion is called pumping. Several methods in pumping. They are by optical pumping, electrical discharge, atom to atom collision, laser construction. To construct the laser setup, there are three things required. That is active medium. Active medium is nothing but in which the population inversion takes place. Next one is pumping source or pumping method, which is used to achieve population inversion. The third one is optical resonator, which is used to increase the intensity of the light using multiple reflections. Next, we are going to see about the types of laser. So, based on active medium, we have several types of laser. The first one is solid state lasers. For example, ruby laser, indiog laser. Ruby laser is the first solid type laser. Next one is liquid laser. If the active medium is in liquid, it's called liquid lasers. Here European benzyl acetonate is the liquid lasers example. Third one is gas. If the active medium is in the form of gas, it's called gas lasers. Example, argon laser, carbon dioxide laser, helium neon laser. Then the laser is made up of semiconductor. There are semiconductor lasers. Gallium arsenide diode laser is the example of semiconductor laser. After understanding all the concepts, we will learn how ruby laser works and indiog laser works, and we will see subsequently. Thank you.